Hey students, this is lesson 8.5. We're going to learn about vectors. We're going to learn how to describe vectors and to solve problems involving vector addition. I'm going to skip over this, so I might do this in class with you and maybe provide it as an extra credit opportunity. So go ahead and pause here and do the review if you'd like. Some important definitions, and I'll talk about those in a second. All right, describing a vector, I'll kind of define a few things as we go here. We use ordered pairs that look like this to describe vectors, and the numbers inside those are ordered pairs that represent a position on a coordinate plane. We use trigonometry to find those values because a vector, it has a magnitude and a direction. And the direction and the magnitude help us figure out the coordinates associated with that point. So here's how you do that. So notice that this 49-degree angle is below the x-axis. So if I just draw in a line there, then I have my y value, which is a negative value because it's below the x-axis, and I can put my x value right there. So the distance from A to B is x units horizontally and then y units vertically. And I know that x is a positive value because it's going to the right, and I know that y is a negative value. Now I can use trigonometry to find that. So y, you might notice, is the side opposite the 49-degree angle, and 15 is the hypotenuse. So I'm going to use the sine to find y. The sine of 49 degrees is equal to y, the side opposite, over 15, the hypotenuse. And then I can use the cosine to get my x value. The cosine of 49 degrees is equal to x, the adjacent side, over the hypotenuse. So the math I need to do here is y is equal to 15 times the sine of 49 degrees, which is about 11.3. And then x is equal to 15 times the cosine of 49 degrees, which is about 9.8. The only thing I'm going to change here is, since y is below the x-axis, I know that's a negative number, so we're going to make that negative 113. So my vector is, and we use these kind of vector type of brackets, my x value is 9.8, my y value is negative 11.3. And if you did 9.8 squared plus negative 11.3 squared, you would get 15 squared using Pythagorean theorem. All right, go ahead and you try that. Pause if you'd like. All right, to describe a vector, we're talking about a direction. And so to describe each of these, just look at the arrow. And we're talking about this arrow is, that angle is formed by a line going that way, and this one a line going this way. So the way we're going to describe it is, look at the way the arrow is pointed. It's pointed north, on the north side of the x-axis. And it's on the east side of the y-axis. So the way we're going to describe this is we're going to say that this vector is 31 degrees north of east. Now some of you might be thinking, well, why didn't you say east of north? And east of north would be describing that angle there. So you could actually call it 59 degrees east of north, but since we're given the 31 degree angle, we're going to say it's 31 degrees north of east. This next one is it's south of the x-axis, and it is west of the y-axis. So we're going to say it's 36 degrees, and we're going in a south direction of the x-axis, and in the west direction of the y-axis. So it's 36 degrees south of west. So if we were heading west, this angle is pushing us to the south of that direction. All right, go ahead and try that. All right, a ship begins a cruise and docks 120 miles east and 45 miles south of where it began. The result of the trip can be described by the vector 120, negative 45 to the nearest tenth. What are the magnitude and direction of the trip vector? So if we have an x and a y axis, and 120, negative 45 means we're going east 120 because it's a positive direction, and 45 south. So I'm just going to guess that it's right here. So on my axis, I can say I went 120 this way and then 45 down this way. So there's my vector right there. It ends right there at that point, and that point is 120, negative 45. All right, we want to know what is the magnitude in the direction. Well, the magnitude is the length of this. We'll call that d. That line, and we can just get that by using Pythagorean theorem. We'll just do 120 squared plus negative 45 squared, which is the same as positive 45 squared. And if we square those, add them together, take the square root, we get, let's see, 16,425, which is about 128.2. So we have to eliminate A and B now from our choices. Now we just need to get this angle right here, and to get that angle we're going to use a little trigonometry. Since we're given the two legs of the right triangle, that would be the opposite and adjacent sides. So we have the tangent going on here. The tangent of x is equal to the side opposite that angle divided by the side adjacent. And the negatives don't make a difference with these either, but we're going to do 45 over 120. So this is where we need to use the inverse of the tangent. X is equal to the tangent inverse of 45 over 120. Again, make sure your calculator is in degree mode when you do this. And if you do that, you should get about 20.6. So that is our choice, D. And it's south of east because that angle is right in here, which is on the south side of the x-axis, and it's east of the y-axis. All right. I'll let you try one of those. Go ahead and fill in the value, see if you get it right. All right, to add vectors, it's not very difficult. All you do is add the x coordinates and then add the y coordinates. And you can add two vectors that way. So we want to add vectors A plus vector B, and that equals x of 1 plus x of 2, and then y sub 1 plus y sub 2 from each of those vectors. So we want to do 5 plus negative 3 and 2 plus 3, and that's equal to 2, 5. All right. All right, flying vectors. An airplane flies due east at a speed of 275. There's a crosswind blowing due south at a speed of 15. What are the plane's resultant speed and direction? It's a little picture of this deal. So the airplane is flying this way, due east. This would be east, this would be north, at a speed of 275. Well, we can just represent that as a distance on there. So it's going 275 this way, miles every hour. And then the crosswind is blowing south, so at 15 miles per hour. And so the airplane is going to take a course blown by the wind this way. The result, and since it's a south, we can call that point the vector 275, negative 15. Well, we want to know the resultant speed and the directions. The speed is the magnitude, or in this case, the length of that line there. So we're going to just say that d is equal to 275 squared plus 15 squared, which is about 275.4 miles per hour. So the wind is adding a little bit to the plane's speed. And then the direction is, we can get that from, the direction is this angle right there, we'll call it x. And we have the side opposite and the side adjacent again, so we can say that the tangent of x is equal to 15 over 275. So x is equal to the tangent inverse of that ratio. And that's about 3.1 degrees. So in the end, we're going to say that the resultant speed and direction is, the speed is 275.4 miles per hour. That's right here. And the direction is 3.1 degrees south of east. All right, go ahead, you try that. This one's a little different. The boat is going to be heading upriver, and it's kind of going against the flow of the river. And this time the speed of the power boat is represented by the hypotenuse. And this is the solution to that problem. All right. So the last thing here, your friend says that the magnitude of the vector 10, 7 is greater than the magnitude of the vector negative 10, 7 because the coordinates of 10, 7 are positive. Coordinates of negative 10, 7 are negative. Explain why your friend's statement is incorrect. So, well, if we just substitute in the values and find the magnitude of each of these vectors, we can get, for this one we get 10 squared, which is 100, and then 49, which is square root of 149. For this one we get 100 also 149, which is the square root of 149. And our friend's statement is incorrect because squaring opposites gives the same answers. If you square n, that is equal to squaring the opposite of n. All right, that's the end of the lesson. I'll see you tomorrow.